Good evening, everyone. First of all, I would like to say thank you very much, no, for inviting me again as your resource speaker. Uh, I am being honored to be a part, no, of this webinar about current trends in machine learning, organized by Institute of Engineering Research and Publication, or IFERD. Today, we cannot imagine a life without research. It has become an integral part of our life. Such conference gives opportunity to everyone to bring those ideas on the table. My message to all the participants in this webinar is to carry it out and participate on more on research and development in the area of engineering and technology, which is very important in the progress of our society. I would like to extend my thanks to all the participants who have joined in IFERD and made this webinar be one of many fruitful exploits we engage in further research and development. Thank you very much. So, okay. Can I share my presentation right now? Okay. Okay, so my topic now in this webinar is all about current trends in machine learning. So basically, I'm Professor Jake Rodriguez Pomperada. I am currently employed as a full-time science research specialist at Technological University of the Philippines, Visayas, in Talisay City, Negros Occidental, in the Philippines. So basically, before we can proceed now with the current trends in machine learning, we have to understand and define what is machine learning. As technology advancement, the integration of artificial intelligence in information technology is currently being applied in different areas, including machine learning. So by each description, it is a subfield of artificial intelligence which is broadly defined as the capability of a machine to imitate intelligent human behavior. Artificial intelligence systems are used to perform complex tasks in a way that is similar to how humans solve problems, according to Brown. Currently, with the evolution of technology and the advancement of computer hardware and software, including the algorithms, it becomes already a part that we are already developing smart system or information systems, which becomes an integral part in information technology. The goal of AI is to create computer models that exhibit intelligent behaviors like human, according to Boris Katz, a principal research scientist and head of the InfoLab group of CSAIL. This means that machines that can recognize a visual scene, understand a text written in a natural language, or perform an action in the physical world. Machine learning is one way to use AI, or artificial intelligence. It was defined in the 1950s by artificial intelligence or AI pioneer Arthur Samuel as the field of study that gives computers the ability to learn without explicitly being programmed. So I have here the machine learning timeline. It is started in 1950 by Alan Turing, who is also considered as the father of computer science. Created tests to check if a machine could fool a human being into believing it was talking to a machine. By 1952, the first computer learning program, a game of checkers, was written by Arthur Samuel. By 1957, the first neural network for computers, the perception, was invented by Frank Rosenbaum, which simulate the thought processes of human brain. By 1967, the nearest neighbor algorithm was written. By 1979, students of Stanford University, California, invented Stanford Cart, which could navigate and avoid obstacles of its own. By 1997, IBM Deep Blue beats the world champion at chess. By 2002, a software library for machine learning named Torch is first released. And then recently, in 2016, AlphaGo algorithm developed by Google DeepMind managed to win 5 games out of 5 in the Chinese board games Go competition. So, question is, how does machine learning works? Machine learning is made up of 3 parts. The first part is the computational algorithm at the core of making determinations. Second, variables and features that make up the decision. Third, base knowledge for which the answer is known that trains the system to learn. Initially, the model is fed parameter data for which the answer is known. The algorithm is then run and adjusts are made until the algorithm's outputs learning agrees with the known answer. At this point, increasing amounts of data are input to help system learn and process higher computational decision. Why machine learning is important? Machine learning is important because it gives enterprises a view of trends in customer behavior and business operational patterns, as well as supports the development of new products. Excuse me. Many of today's leading companies like Facebook, Google, and Uber make machine learning a central part of their operations. Machine learning has become significant competitive differentiator for many companies, according to Burns in 2022. Data is the lifeblood of all business. Data-driven decisions increasingly make the difference between keeping up with competition or failing further behind. Machine learning can be the key to unlocking the value of corporate and customer data, enacting decisions that keep a company ahead of the competition. What are the different types of machine learning? So here in this slide, I will discuss now the different types of machine learning. Classical machine learning is often characterized by how an algorithm learns to become more accurate in its predictions. There are four basic approaches: supervised learning, unsupervised learning, semi-supervised learning, and reinforced learning. The type of algorithm data scientists choose to use depends on what type of data that they want to predict. The first one, supervised learning. In this type of machine learning, data scientists supplies algorithms which enable training data and define the variables they want the algorithm to assess for correlations. Both the input and the output of the algorithms is specified. The second, unsupervised learning. This type of machine learning involves algorithms that train on labeled data. The algorithm scans through data sets looking for any meaningful connection. The data that algorithms train, as well as the predictions or recommendations the output, are predefined. Third, semi-supervised learning. This approach to machine learning involves a mix of two preceding types. Data scientists may feed an algorithm mostly labeled training data, but the model is free to explore the data on its own and develop its own understanding of the data set. Fourth, reinforced learning. Data scientists typically use reinforcement learning to teach a machine to complete a full step process for which there are clearly defined rules. Data scientists program an algorithm to complete a task and give it positive or negative cues as it works out how to complete a task. But for the most part, the algorithm decides on its own what steps to take along the way. What are the advantages and disadvantages of machine learning? Machine learning has seen use cases ranging from predicting customer behavior to forming the operating system for self-driving cars. A good example of self-driving cars is the Tesla cars. When it comes to advantages, machine learning can help enterprises understand their customer at a deeper level. By collecting customer data and correlating it with behaviors over time. Machine learning algorithms can learn associations and help teams tailor product development and marketing initiatives to customer demand. Some companies use machine learning as primary driver in their business models. Uber, for example, uses algorithms to match drivers with riders. Google uses machine learning to surface the ride advertisements in searches. But machine learning comes with disadvantages. First and foremost, it can be expensive. Machine learning projects are typically driven by data scientists who command high salaries. These projects also require software infrastructure that can be expensive. There is also the problem of machine learning bias. Algorithms trained on datasets that exclude certain populations or certain errors can lead to inaccurate models of the world that at least failed and at most are discriminatory when an enterprise bases core processes on biased models, it can run into regulatory and reputational harm. Who's using machine learning and what is used for? Today's learning is used in a wide range of applications. Perhaps one of the most well-known examples of machine learning in action is the recommendation engines that powers Facebook news feeds. Facebook uses machine learning to personalize how each member's feed is delivered. If members is frequently stops to read a particular group post, the recommendation engine will start to show more in groups activity earlier in the feed. Behind the scenes, the engine is attempting to reinforce known patterns in the member's online behavior. Should the member change patterns and fail to read posts from the group in the coming weeks, the news feed will adjust accordingly. In addition to recommendation engines and other for machine learning includes the following: customer relationship management or CRM. CRM software can use machine learning models to analyze email and prompt sales team members to respond to the most important messages first. More advanced systems can even recommend potential effective responses. Second, business intelligence. BI or business intelligence in analytics vendors use machine learning in their software to identify potential important data points, patterns of data points, and anomalies. Third, self-driving cars. Machine learning algorithms can even make it possible for semi-autonomous car to recognize a partial visible object and alert the driver. A good example of self-driving cars are the Tesla cars. Okay, we have also here visual assistance. Math assistants typically combine supervised and unsupervised machine learning models to interpret natural speech and supply context. So we have here the current trends in machine learning. First, Internet of Things or IoT in machine learning. The first and most important machine learning developments is Internet of Things or IoT, which the majority of computer employees are looking forward to. As the cornerstone of Internet of Things or IoT, a breakthrough in this area will significantly impact the 5G adoption. Because 5G's tremendous network speed, systems will be able to receive and deliver data at a faster rate. Internet of Things or IoT devices can connect other machines on the system to the Internet. Every year, the number of Internet of Things or IoT devices connected to the network grows dramatically, resulting in significant increase in the amount of data exchange. Next, number 2, automated machine learning. Professionals can design effective tech models that help them in improving efficiency in production by using automated machine learning. As a result, most advancements in the domain of effective task solving are observed. Auto ML or machine learning is mostly used to generate sustainable models that aid in the derivation of job efficiency, particularly in the development sector where the professionals can develop apps without having much programming skills. Third, improve cybersecurity. With the advancement of technology, most applications and appliances have become smart, resulting in significant technological advancement. However, because of these smart appliances are continually connected to the Internet, there is a pressing need for them to be more secure. Tech pros may utilize machine learning to create antivirus models that block any possible cyber attacks and reduce dangers. Next, we have here ethics in artificial intelligence. With the advancement of new technologies such as artificial intelligence and machine learning, defining some ethical guidelines of these technologies is a growing worry. The higher the technology, the higher the ethical standard should be. Machines will be unable to perform efficiently if ethics are not followed, resulting in poor decisions. This is seen in self-driving cars that are already available. The implanted artificial intelligence which serves as vehicle's brain to be blamed for self-driving cars' failure. Automation of natural speech understanding process. A lot of information is being spread about smart home technology, which theoretically works on smart speakers. The process is simplified because of the usage of intelligent voice assistants such as Google, Siri, and Alexa, which connect to smart appliances via non-contact control. These computers already have a high level of accuracy when it comes to detecting human sounds. General adversarial networks. GANs are a smart way of training a generative model by posing the problem as supervised learning problem with sub-models. The generator model, which is trained to generate new examples, and the discriminator model, which tries to classify example as real from the domain or fake from outside the domain generated. The two models are trained in adversarial zero-sum game until discriminator model is tricked roughly half of the time, indicating that the generator model is producing believable examples. We have here also no-code machine learning in artificial intelligence AI. No-code machine learning is exactly what it sounds like. It is the process of creating machine learning applications without having to do a lot of coding. Instead, you can create machine learning application using drag and drop visual interface that meets the majority of the needs. No-code machine learning is derived from no-code software development. This notion is relatively new. It was offered to reduce development time and effort. Instead of writing code by hand, user can utilize specialized tools to build software applications rather than building them from scratch. MLOPS, or Machine Learning Operational Management. Machine learning development has forever been associated with particular issues, such as scalability, the construction of proper machine learning pipelines, the management of sensitive data in scale, and team communication prior to the introduction of machine learning operational managements. MLOPS aims to address these difficulties by establishing best practices for the deployment of machine learning applications. While the phases of machine learning operationalization management are similar to those traditional machine learning development, due to the business objective first design, MLOPS provides more transparency, removes communication gaps, and allows for better scaling. We have also here reinforced learning. The machine learning system learns from experiences with its surroundings in reinforcement learning. To impact value to the observations that the machine learning system perceives, the environment can use a reward or punishment mechanism. Similar to positive reinforcement training for animals, the system will eventually strive to obtain the highest level of reward or value. This has a lot of potential in artificial intelligence or AI for video games or board games. However, where application safely is priority, reinforcement machine learning may not be the ideal option because the algorithm draws conclusions based on random actions. It may purposely make risky decisions while learning. Few shot, one shot, and zero shot learning. Only a small amount of data is used in few shot learning. While it has its drawbacks, it has a wide range of application in disciplines such as image classification, facial recognition, and text classification. Although the fact that a useful model does not require a lot of data is advantageous, it cannot be used for exceedingly complicated problems. One-shot learning, on the other hand, uses even less data. It does, however, have certain applications for facial recognition. For example, a given password ID photo could be compared to a person's image captured by a camera. This just requires existing data and does not necessitate a vast database of information. The concept of zero-shot learning is initially perplexing. Without any beginning data, how can machine learning algorithms work? Zero-shot machine learning systems look at a subject and utilize information about it to anticipate which classification it will fall into. Tiny ML or tiny machine learning. It can take time for a web request to send data to a large server, for it to be processed by a machine learning algorithm and then sent back. Instead, a more desirable approach might be to use machine learning programs to edge devices. We can achieve lower latency, lower power consumption, lower required bandwidth, and ensure user privacy. Another revolutionary transformation in the field of machine learning is tiny ML. Tiny machine learning was inspired by IoT or Internet of Things, and the main idea behind is to enable machine learning driven processes on IoT edge devices and devices with low power consumption. A good example of tiny ML is a wake command that you give to your smartphone, either Hey Siri or Hey Google. The reason behind tiny ML is to make machine learning more versatile and to expand its usability. Several years ago, machine learning development required high computational power to handle the processes. But today, tiny ML can be implemented to almost any device that has sufficient computing power. Okay. Okay, the next in line is, The next in line is machine learning trends in MLOPS. As the name implies, MLOPS was inspired by DevOps methodology. If we address the definition, MLOps is a set of practices for transparent and seamless collaboration of data scientists, development, and operational scientist operations. Before the introduction of MLOps, machine learning development has always been associated with certain challenges like scalability, development of proper ML pipelines, management of sensitive data at a scale, and communication between the teams. MLOps is aimed to resolve these issues by introducing standard practices to ML or machine learning application deployment. While the phases of MLOps are pretty much the same as phases of traditional machine learning development, MLOps brings more transparency, eliminates communication gaps, and allows better scaling due to business objective first design. You can say that MLOps, you may pay much more attention to the process of data collection and cleaning, as well as model training and validation. Hence, enterprises with acute need for scalability will most definitely benefit from the deployment of MLOps approach. So we have also here unsupervised machine learning. Another big thing, as we can see in 2022, is machine learning tends to be unsupervised learning. Again, it is easy to guess its meaning by its name. Unsupervised learning means there is no human intervention in the machine learning process. Instead, the ML model receives unlabeled data and it's free to draw any conclusion based on it. The biggest difference between supervised learning and unsupervised learning is the data. With supervised learning, the data is labeled, meaning people already prepared it for the ML model or machine learning model. With unsupervised learning, data is unlabeled, meaning it does not have any labels and it is not separated into groups or categories. So why would you allow machine learning model to be independent about working with data? Conclusion. While machine learning algorithms has been around for decades, they attained new popularity as artificial intelligence has grown in prominence. Deep learning models, in particular, powers today's most advanced AI application or artificial intelligence applications. Machine learning platforms among enterprise technology most competitive realms with most major vendors including Amazon, Google, Microsoft, IBM, and others racing to sign customers up to for platform services that cover spectrum of machine learning activities including data collection, data preparation, data classification, model building, training, and application development. Machine learning continues to increase its importance to business operation, and AI, artificial intelligence, becomes more practical in enterprise settings. The machine learning platform wars will only intensify. Continued research in deep learning in AI, artificial intelligence, is increasingly focused on developing more general applications. Today's AI models require extensive training in order to produce an algorithm that is highly optimized to perform one task. But some researchers are exploring ways to make models more flexible and are seeking techniques that allow a machine to apply context learned from one task to future different tasks. So I have here my references in my presentation, and then this is the end of my presentation. Thank you very much for learning. If you have some question, I'm ready to answer your questions. Thank you so much, everyone. So question. Okay, so we have here a couple of questions. No? One of the question is the current trend of Metaverse. Which type of machine learning is being used? It is reinforced. Actually, the question of one of our participant about Metaverse, I am very sorry, I am not familiar with this Metaverse, but most of the time the current technology of machine learning that is widely successfully being implemented is supervised machine learning. When we say supervised machine learning, there are still human interaction to provide data, because 100% unsupervised machine learning until now cannot be reached with 100% accuracy. So a majority I can give you an example. Majority of the library that we can use, whatever programming language, let's say for example Java or PHP, there are some machine learning library that we can incorporate, like prediction or forecasting. Most of the time we are just putting some data sets, no, and then the library is the one who will perform the predictions or forecasting for us. And then from our end, as the user or developer, what we can do is just to display the result. So that kind of a machine learning algorithm is still using the supervised machine learning. I hope I can able to give you some insight with your question. Another question here: what is the application of machine learning in water resources? Well, in water resources, we are dealing here with maybe we can dealing here with forecasting. For example, a water utility company can have a set of data. Example, for the last 5 years, how much, no, is the water rain drops, no, in a certain area. So by having that particular data, with the use of machine learning library file, for example, we can predict the rainfall, no, in the upcoming years. Not necessary it is the accurate, but at least we have a baseline, no, of how much the rainfall that we can expect. So if we can expect a small rainfall on the part of the government, for example, or the water utility company can conduct a cloud seeding, no, to increase the rainfall that will fall, no, in a certain year. That is my answer to your question on how machine learning can help in the water resources application. Thank you so much, no, for asking these questions. Thank you very much, everyone. Thank you for inviting me.